Welcome to lesson 10-8. This is a reasoning strategy lesson. The strategy for today is to make a model. You're going to need out a pencil, paper, a ruler, and colors if you so choose. Alright, so today we're just going to practice solving real-life problems by making a model. So the first step for any problem is to understand the problem. So our problem is a box company makes boxes to hold popcorn. Each box is made by cutting the square corners out of a rectangular sheet of cardboard. The rectangle is 8.5 inches by 11 inches. What are the dimensions of the box that will hold the most popcorn if the square corners have side lengths 1 inch, 2 inch, 3 inch, and 4 inches? So to understand, that means we're asking, what is our target question? What's the point of this problem? So let's go through our problem and highlight the key information. What's the key question? Let's understand the problem. Let's understand what are we looking for. So we're told they make boxes that hold popcorn. Each box is made by cutting the square corners out. The rectangle is 8.5 by 11 inches. What are the dimensions of the box that will hold the most popcorn? Okay, so we're essentially trying to find what it just underlined. What are the dimensions of a box? Okay, so dimensions of a box, so we're thinking a 3D figure, right? It's going to be a 3D figure. So we're trying to maximize, right, the most popcorn. We want to maximize the volume of a box. So which box, 1 inch, 2 inch, 3 inch, or 4 inch, is going to result in the greatest volume? Which holds the most? Okay? So that's what our target question is. Now which box is going to hold the most popcorn? So which one has the most space in it? We know space in a 3D figure, we're talking about then volume. Okay, so our second step after understanding is to make a plan. How are we going to go about solving this problem? Well, okay, so we want the greatest amount, right? We want the greatest amount of popcorn. And we're thinking of this 3D box. Whoops. It's going to hold little popcorn kernels in it. So the question is, how are we going to find that? Well, 3D, we're looking at length, width, and height. This is a rectangular prism, because remember we were given a rectangle piece of paper to start with. So let's look at the volume. So our plan, let's find the volume of each possible box. Right, because they told us if we look back at our problem, 1 inches, 2 inches, 3 inches, or 4 inches are what we could be taking out of the corner of our piece of paper. Right, they're going to give us a piece of paper, we're going to be cutting out the corners. Which one, when we then fold up the sides here, is going to result in the greatest space inside the box? So we can then, right, let's draw that again. if we were to cut out 1 inch by 1 inch, right, our whole length we were given is 8.5 by 11 inches. So rectangle is 8.5. Let's try that again. 8.5 by 11. Should actually really label those the other direction to match my shape. Oh, this is the longer size. Okay, so I can take this and say then, I have 8.5 by 11 as my rectangular piece of paper. So if I cut out all those little 1 inch corners I just showed you, we're going to then fold on the dotted lines. So we're going to cut these out, that's going to be gone. We're going to fold these sides up. Right, so we cut that out from the corners in order to make a box. Then we fold along the dotted lines. So now these two sides meet. Forms a not very deep, but a long box. So let's find let's go ahead now. We've understood, we've kind of made a plan. We're going to find the volume of the different possible figures because we know it could be 1 inch, 2 inch, 3 inch, or 4 inches cut out. Right, that's our options. So now we can solve. Step 3 is to actually solve the problem. So to solve the problem, well, our plan is to find the volume of each. So let's think about what's the volume. How are you going to find the volume? Well, rectangular prism. We learned this in 10-6. The volume is the base area times the height. Base area times height, so if these are inch cutouts over here, right, these are the possible cutouts we could have. We're going to go ahead and find the volume for the shapes of each of these. So let's go ahead and do the first. So the volume, if I'm cutting out 1 inch by 1 inch by 1 inch in each corner, this was my 11 inch long, this is my 8.5 inch long. So if I cut out 1 inch on each end, this side is now not 11, but it becomes 9. If I cut out 1 inch here and here, my 8.5 becomes 6.5 long. Okay, so let's go ahead now and find the volume of the box. Well, so the base area, remember this is our fold. So the base area is just this inside, what's going to be the bottom of the box. So that's a rectangle, right? So we'll do length times width. So it's going to be 6.5 times 9. And then your height, well, when we fold up this corner, the corners of our box, how high is that? It's only 1 inch, right? Because we cut out a 1 inch corner, times 1. So the volume of your 1 inch box, so your 1 inch box, 6.5 times 9 by 1. So the volume of this box is going to be 58.5 inches cubed. Okay, so that's our first box. Let's go ahead and do our second box. Okay, in this case we start again with 11 by 8.5. So now the corner I'm cutting out is 2 by 2, right? On each end. So now the length along this fold like this target area here. What's going to be 11 minus 4 because there's 2 on each end? 2 plus 2 is 4. So this 11 minus 4 is 7. Then my 8.5 minus 4 is going to be 4.5. So when I find the volume of my second box, our 2-inch cutout box, well, it's still a rectangular base, length times width. So 7 times 4.5. And then your height now is going to be this 2-inch high when you make your fold. So times 2. So the volume of your second box here is 7.5, or 7 times 4.5 times 2, which is 63 inches cubed. Okay, so we know the second box is bigger than the first. Okay, so we can cross out our maximum volume is not going to be our 1-inch box. Let's go ahead and draw our third box. So our third box would be 3 by 3 that we're cutting out. This was our 11-inch, this is our 8.5-inch side. Okay, 3 by 3. So volume equals the base area times the height. So the volume equals, it's going to be this inside portion again that is our base area, right along the fold. So 11 minus, well, 3 and 3 on each side. So that's 6, so 11 minus 6 is 5. And then 8.5 minus 6 is only 2.5. It's getting really tiny. So our base area is going to be 5 times 2.5. And then your height, well, we're folding up our box 3 inches high. So the volume equals 5 times 2.5 times 3. That's 37.5 inches cubed. Okay, 37.5 for our 3-inch shape. So we can go back and look at it and say 63 inches cubed for our second box. So we know 3 is not the maximum volume. Let's go ahead and check our fourth shape for our 4-inch cutouts. So now from our 11-inch side, our 8.5-inch side, if we were to cut out 4 by 4-inch squares, we're not going to be left with much. 11 minus 4 and 4, so 11 minus 8 is 3. And then 8.5 minus 4 and 4 is 8 is only 0.5. So the volume of our 4-inch cutout box equals, we're going to have a really tiny little base. It's just going to be 3 by 0.5. 3 by 0.5. And then our height is now 4 inches tall. So times 4. So the volume of our 4-inch box equals 3 times 0.5 times 4. So that's only 6 inches cubed. So the bigger the cutout, after a certain point it gets smaller. So 6 inches is not a very large volume. So the 2-inch cutout is going to be our answer. Oops. So back to our target question. Let's see. So we say the 2-inch cutout was our answer. So let's go back and double check that we got that we met our target question, right? So when we understood our question, which box holds the most, we wanted to maximize the volume. Well, we checked all 4 boxes, right? 1-inch, 2-inch, 3-inch, and 4-inch. Yes, we used the 8.5 and the 11-inch rectangle. And if we look at our different measurements that we got, we had 58.5 inches for the first box, then up to 63 inches for the second, then 37.5, and then 6. And does that make sense? We can check it by saying, does it make sense? Well, and if you think about it, the more, whoops, as we went forward, and as we cut out more and more from our box, right, we only ended up with a 0.5 inch side and a width, 0.5 by a 3 inch long side. So that makes sense. And then it was only 4 inches tall on that last one. So it makes sense that even though the 4 cut out, it's going to be a really small box. The dimensions we got for, that box turned out funny. The dimensions we got for the third box were 5 inch long by 2.5 inch width by a 3 inch tall. This is a little bit bigger, but then our second box we had was too high. Oops, let's draw that shorter. It was only too high. But it was 7 inches long and 4.5 inches deep. So it makes sense that this would be your largest box because 7 by 4.5 by 2 is clearly a much larger number than 4 by 3 by 1/2. That's a really tiny box. So yes, it makes sense. So by comparing the different dimensions, of the individual boxes, we were able to say that yes, our volume comparisons are logical as well. They make sense. Alright, so by the strategy for this problem, I drew pictures, right, of each model in order to figure out what the dimensions were. So this make a model strategy, it's kind of like drawing it out, right? It's taking something, a real life problem, and it's saying, can you either visualize it, make a model that you can label, right, with the dimensions, and then solve for a target question. So you're in class practice. I know, it's word problems, but it is applicable to real life. If you are working for a company and they wanted to know, how am I going to sell, find a box that holds the most popcorn, like that's a relevant, good question. So you're going to do some practice with this. This is on page 546. You're going to do numbers. Number 1 is really similar to what we just did. You're kind of following the same steps. So I want you to go ahead and do number 1. Oops. 1 and 2. And then you're going to do some ones where practice problems 1 and 2 require the make a model strategy. But then you can do some ones where you get to choose your own strategy, whether that's you're doing guess and check, you're drawing a picture, you're making a model. You get to choose. So you'll do 1, 2, 3, and 5. And then your homework is going to be your practice book, page 10-7. Alright, go ahead and get started on your in-class assignment.